ordinary temperature, but is instantly coagulated when the liquid containing it is heated to the boiling point. When the clarified juice of nutritious vegetables, such as cauliflower, asparagus, mangel wurzel, or turnips, is made to boil, a coagulum is formed, which it is absolutely impossible to distinguish from the substance which separates as a coagulum when the serum of blood or the white of an egg, diluted with water, are heated to the boiling point. This is vegetable albumin. It is found in the greatest abundance in certain seeds, in nuts, almonds, and others, in which the starch of the gramineae is replaced by oil. The third nitrogenized constituent of the vegetable food of animals is vegetable casein. It is chiefly found in the seeds of peas, beans, lentils, and similar leguminous seeds. Like vegetable albumin, it is soluble in water, but differs from it in this, that its solution is not coagulated by heat. When the solution is heated or evaporated, a skin forms on its surface, and the addition of an acid causes a coagulum, just as in animal milk. These three nitrogenized compounds, vegetable fibrin, albumin, and casein, are the true nitrogenized constituents of the food of graminivorous animals. All other nitrogenized compounds occurring in plants are either rejected by animals, as in the case of the characteristic principles of poisonous and medicinal plants, or else they occur in the food in such very small proportion that they cannot possibly contribute to the increase of mass in the animal body. The chemical analysis of these three substances has led to the very interesting result that they contain the same organic elements, united in the same proportion by weight, and, what is still more remarkable, that they are identical in composition with the chief constituents of blood, animal fibrin, and albumin. They all three dissolve in concentrated muriatic acid with the same deep purple color, and even in their physical characters, animal fibrin and albumin are in no respect different from vegetable fibrin and albumin. It is especially to be noticed that by the phrase identity of composition we do not here intend mere similarity, but that even in regard to the presence and relative amount of sulfur, phosphorus, and phosphate of lime, no difference can be observed. How beautifully and admirably simple, with the aid of these discoveries, appears the process of nutrition in animals, the formation of their organs in which vitality chiefly resides. Those vegetable principles which in animals are used to form blood contain the chief constituents of blood, fibrin and albumin, ready formed, as far as regards their composition. All plants, besides, contain a certain quantity of iron, which reappears in the coloring matter of the blood. Vegetable fibrin and animal fibrin, vegetable albumin and animal albumin, hardly differ, even in form. If these principles be wanting in the food, the nutrition of the animal is arrested, and when they are present, the graminivorous animal obtains in its foods the very same principles on the presence of which the nutrition of the carnivore entirely depends. Vegetables produce in their organism the blood of all animals, for the carnivora, in consuming the blood and flesh of the graminivora, consume, strictly speaking, only the vegetable principles which have served for the nutrition of the latter. Vegetable fibrin and albumin take the form in the stomach of the graminivorous animal as animal fibrin and albumin do in that of the carnivorous animal. From what has been said, it follows that the development of the animal organism and its growth are dependent on the reception of certain principles identical with the chief constituents of blood. In this sense we may say that the animal organism gives to the blood only its form, that it is incapable of creating blood out of other substances which do not already contain the chief constituents of that fluid. We cannot, indeed, maintain that the animal organism has no power to form other compounds, for we know that it is capable of producing an extensive series of compounds, differing in composition from the chief constituents of blood, but these last, which form the starting point of the series, it cannot produce. The animal organism is a higher kind of vegetable, the development of which begins with those substances with the production of which the life of an ordinary vegetable ends. As soon as the latter has borne seed, it dies, or a period of its life comes to a termination. In that endless series of compounds, which begins with carbonic acid, ammonia, and water, the sources of the nutrition of vegetables, and includes the most complex constituents of the animal brain, there is no blank, no interruption. The first substance capable of affording nutriment to animals is the last product of the creative energy of vegetables. The substance of cellular tissue and of membranes, of the brain and nerves, these the vegetable cannot produce. The seemingly miraculous in the production agency of vegetables disappears in a great degree when we reflect that the production of the constituents of blood cannot appear more surprising than the occurrence of the fat of beef and mutton in cocoa beans, of human fat in olive oil, of the principal ingredient of butter in palm oil, and of horse fat and train oil in certain oily seeds. End of Letter 8.